One of the things that is disturbing to me is I'm seeing these AI vendors, many of them who came from the IT space and who are coming down into the plant floor, and they're pushing their generative AI product onto the plant floor. And they're saying, this is going to solve all your problems on the plant floor. Well, what do we know about generative AI? Some of the limitations. Obviously, the biggest one is hallucinations. So that's where, for your listeners who don't know, that's where the generative AI will literally make something up, just out of whole cloth, just make something up. On the plant floor, that could have deadly consequences. That's a really bad situation.
We're going through something absolutely historic.
Technologies across the board are growing exponentially.
It's a disruption that's going to completely redefine the way businesses compete.
In the next decade, we're going to lose 40% of today's Fortune 500 companies.
The exponential growth of computing is continuing.
AI is nowhere near its full potential.
Whether you like it or not, that the future cannot be stopped by anyone.
Welcome back to the Future Tech and Foresight podcast. I'm your AI host, Mark Verbankoff's deepfake avatar, and this is episode number 227. Manufacturing is undergoing a fundamental shift from rigid assembly line systems to dynamic data-driven environments powered by artificial intelligence. This episode explores how industrial AI is moving beyond predictive maintenance into real-time process optimization, where autonomous systems continuously learn, adapt, and outperform even the most experienced human operators. From improving product quality to minimizing waste, AI is reshaping how factories operate at their core. The conversation dives into real-world applications of autonomous AI, including its ability to fine-tune complex systems and deliver measurable results like significant energy savings and operational efficiency. It also addresses one of the industry's biggest challenges, the loss of institutional knowledge as experienced workers retire, and how AI can preserve and scale that expertise. Looking ahead, the episode explores the slow but inevitable adoption of AI in manufacturing and what the future could look like as autonomous systems become more deeply embedded in industrial environments. Now, a little bit about Bryan. Bryan DeBois is the Director of Industrial AI at Robasys, one of the largest independent global system integrators focused on manufacturing and industrial customers. During the 20 years he's worked there, he has focused on manufacturing execution systems, historians, plant floor software, and Level 3 information solutions in the operational technology space. Bryan's current focus is on operationalizing technologies such as artificial intelligence, data infrastructure, and advanced analytics to boost the productivity of global manufacturers.
Perfect. Well, Bryan, thank you so much for joining the podcast today to talk about industrial AI, manufacturing, and I guess the future of these very interesting industries and tools. So thanks again for your time.
Yeah, thanks for having me, Mark.
So the way that I like to start off all podcasts is to get a little bit of a sense of how my guests have entered into the world and the domain in which they're working. What brought you into industrial AI? Was it manufacturing first? Was it AI first? What's that journey look like?
Yeah, for sure. So for me, you got to rewind all the way back to the late 90s, early 2000s. So I had a degree in computer science, and I'm graduating from the University of Akron, and really knew nothing about manufacturing. I was a big fan of the show How It's Made, but that was about the extent of my knowledge of manufacturing. And I met Robasys, my company that I work for. I met them at a career fair at University of Akron and started as a co-op here in 2000 and then started full-time in 2002. So I've actually spent my whole professional career here. And what that's given me is the opportunity. I've now been in, probably near 100 different plants and seeing these processes and seeing how things are made firsthand, which I love. That is still, I'm still like a little kid when I get to walk into these plants and see how things are made. It's so cool. The stuff that we just kind of take for granted every day.
Yeah.
And then it was in 2019 where Robasys, so Robasys has been around now for a while. So in 2019, we hit our 30-year anniversary. And, as a company that is focused on, we're a system integrator for manufacturing and industrial customers. And so in 2019, we hit our 30-year anniversary and we started to look out and say, what's next? What does the future look like? And so we identified 3 different areas, centers of excellence that we wanted to spin up in 2019. And so one of those was industrial AI. I was fortunate enough to be named the director of that center of excellence. And so we've actually been at this for quite a while in my company, which is good because many of our peers, are just now starting down that AI journey. Meanwhile, we've got real AI models that are delivered and running in the field and in plants, and we know where all the landmines are. We know how to make sure that these projects are a success, because we've been doing it now for quite a while.
Very interesting. Well, I think the bulk of the conversation will certainly be about that. I just want to maybe back up a little bit and maybe get a little bit of context, especially for people who haven't been fully aware of like manufacturing. It's been discussed on the podcast a number of times, but not everybody listens to every episode. And because you've been in these in I guess very diverse plants over the years, clearly there are some plants that are more advanced than others. And I think the question I'm asking is like, before we jump into AI, there's obviously been a number of other technologies that these plants have been adopting over the last several decades at various levels. Have there been like levels or waves of new technologies, like sensors, for instance, that many plants have taken on, and have those things like really increased the efficiency and the operating capacity of these plants over the last several decades?
There absolutely has. And I mean, you go back to, so many people talk about how, and it's debatable whether or not we're in the 4th industrial wave
Right.
or the 5th industrial uh, uh, revolution wave phase. And so if you go all the way back, and I don't even remember them all, but I think the first one was basically the Model T, and you've got some automation and things like that. And then you have pneumatics, and then you have the adoption of relays. So now you've got electricity kind of running these plants, and then you get to transistors and computers running these plants. And so now we're still in this 4th industrial revolution, and many people are starting to say we're on the precipice of the 5th. I think personally that when we get to, I think that AI will either mark the end of the 4th industrial revolution or the beginning of the 5th. I think that one of the things that a lot of people don't realize about the plant floor, and I think that people a lot of times still have the wrong impression of what a plant floor looks like, right? It's
Right.
dirty, it's dingy, it's crowded, you're at an assembly line, and like, of course, that's not at all what there's, you can probably find plants that look like that still, but many of these plants are very modern. And we've been doing data collection. I mean, I've been at this now for 26 years. Like, so we've been doing data collection and modernization efforts for all this time. I think one of the things when I started my career, we were still in a lot of ways teaching customers on why they needed to collect this data. So I'll never forget, I actually had a customer who said, "Why would we collect this data? We just throw it out. What would we ever do with it?" Right now, this is in the early 2000s. So it
Right.
sounds quaint to say that now,
Yeah.
but the answer is okay, now this is why you saved all that data, right? Because now we can leverage that data and we can build AI models that are going to make you more efficient. And so that's really kind of the message around that. So all of that work that we've been doing over those decades, like you talked about, that was to get, in my mind, to get to this AI future or present that we can actually start to take advantage of these things.
Super interesting. And are there any, I don't know if low-hanging fruit is the right term, but are there any kind of like simple use cases or early use cases that these plants are adopting industrial AI for? Like, are there like 3 things that most of these plants are starting to do with industrial AI, or is it kind of super diverse and everybody's testing different things?
Definitely the latter. Everyone's trying to figure out where AI is going to have the impact for them. But broadly, we can put, probably 3-ish buckets. We can put everything under it. And so the first one, the one that we really emphasize, which actually is not where the industry goes, and I'll tell you that in a second, but where most of the industry is looking, where we're looking to have the most immediate impact is typically what we would call process optimization. So that's how can we run these processes better? How can we either increase quality, decrease scrap, increase yield, increase throughput, of the product, make better product coming off the line faster, cheaper, right? But of higher quality. Why that's really important right now, though, and one of the things you may have seen, kind of one of those macro trends, is that we have lost, with the retirement of the baby boomers, we have lost all that expertise on the plant floor. The folks who knew how best to run this equipment and maintain this equipment are gone or will be gone soon. And so my clients are struggling because the incoming workforce, better, worse, and different, I don't want to, generational things, I don't really weigh in on that. I think every generation has a lot to offer, but they have different priorities, and they're not really interested in spending a long time, the next decade of their career learning how best to run this part of the process, right? Vinyl extrusion, or making some metal part, or making some, filling some can with some kind of food or whatever. I mean, they're just not that interested in learning how that works. They're really like digging in. In fact, most of my clients are saying that what we're seeing out of the incoming workforce is they're primarily treating these jobs as an entry-level job. They'll work for 6 months if you're lucky, and then they're going to move on to the next job. And so they have high turnover. They have low tenure in these positions. And so process optimization in a lot of ways is the most key thing, because you're making product every single day, hopefully. And so if you can move the needle on that, you can have an immediate bottom line impact. And there are clients of mine who are saying to me, the line doesn't run as well as it used to. So they're now, in a lot of ways, just trying to get back to how it ran 5 to 6 years ago, and just trying to maintain the status quo. And so they're looking to AI to be able to augment that knowledge, to augment that expertise, and help those novice operators be able to operate the line as well as it used to. So that's the first one, would be the process optimization. The second primary area that we're looking at is energy reduction, especially now with the advent of data centers. And I don't know if you're seeing it. I'm certainly seeing my electric bill is going up. And we're just residential. When you talk about the amount of electricity that some of these plants use, like it becomes a very big deal when you see double, triple electric bills because of these data centers. And so energy utilization, energy reduction is becoming another major area of focus. And I've been saying to people, look, regardless of if it's just a straight like cost thing, like we're seeing now, or in previous years, it was more about sustainability and ESG scores and trying to make sure that you're, either way, there is no technology in the wings that is somehow going to be able to give us double-digit, even single-digit % decreases in energy utilization. Like if there was, it would already be here, right? AI is that technology that can give us that reduction in energy utilization. And so I try to emphasize that, like if you're waiting for some technology to emerge, it's not coming. What we have is we have AI today, and it's very capable of being able to get to single and double-digit reductions in energy utilization, if you implement it right. So that's the second area. And then the third area, and the one that is the primary focus for a lot of people in our industry, is asset downtime. So unplanned downtime, though a lot of times you'll hear the term predictive maintenance, asset health, asset monitoring. But the idea is that can we predict when, or in some way, can we monitor the health of this asset, this equipment? And of course, they've got big multi-million-dollar equipment on the plant floor. Can we monitor the health of it to make sure that we reduce or avoid unplanned downtime? Because what that means, and I've been in plants that are experiencing unplanned downtime, and it stinks, man. You've got your whole staff sitting around doing nothing. They're on their phones in the corner, whatever, because there's literally nothing they can do until the machine is fixed and back up and running. So you lose, besides the production, the lost opportunity cost in production, you've also, you're paying for all this labor. I mean, it's just a bad situation for unplanned downtime. And so I understand that there's a focus there on trying to fix that. My take on it is this. I think that many of the AI vendors in our space overstate their ability to actually detect that asset health, which I think is pretty bad when they're selling a certain thing to customers and then the customer saying, I'm not really getting what I paid for here, right? So I think that's part of the problem. And the second part of the problem is that, hopefully, while unplanned downtime is very expensive, hopefully it's not happening that often, right? Hopefully it's a couple of times a
Right.
year, hopefully it's no more than every 6 weeks or something like that. Whereas you're making product every day. So if we can increase quality, reduce scrap, if we can, those first two items, if we can maximize those have an immediate bottom line impact. Whereas reducing unplanned downtime, super important. It's very expensive, but I don't see the reason to actually lead with that on all of these engagements.
Very interesting. Very interesting. So for process optimization and energy optimization, could you dive into that, or the term now is double click on that a little bit, as to like specifically how industrial AI, which is different from generative AI, as we discussed before the recording, how exactly this industrial AI is bringing about those gains? And you said it's like, double percentage, or even like 100% sometimes, or more than that. So I'm very, very curious to hear about that.
Yeah. And I'll give you two specific examples here. So here's a case study when you talk about process optimization. So this was a company that makes glass bottles. All right. Now, the process of making glass bottles is that you have molten glass, and it drops down in what's called a molten gob of glass. And it drops into a mold, air is blown in, and then that's how you get a glass bottle. Well, and this process is very fast. So this happens every 2 seconds. Another glass gob falls into a mold. Well, it turns out that the size, the weight, and the drop angle of the glass gob has a direct correlation to what the final quality of the bottle is.
That's so cool.
Yeah, it really is. And so so when we were working with this customer, they said, well, look, so this is one of those areas where in manufacturing, and we see this way more than you would think, where the skill, the expertise of the operator has a direct impact on the quality of the bottles. So how they turn the knobs and how good they are at the, so a gob falls down, there's a piston behind it that they can control that puts pressure on it. Then that you have the cutters that come in, like controlling all those little pieces of the process, depending on how well they control it, is how you get better or worse bottles. And, that's a big deal, because what they were telling us is that it's a process that takes a light touch. It's very finicky. It's an art, not a science, to kind of control it really well. And what they said was that if the process drifts, so what that means is if they start making bad bottles, off-spec bottles, they could be making off-spec bottles for as long as 20 minutes before they get back to making on-spec bottles. So again, every 2 seconds, a new bottle's being made. So you're talking about throwing out large volumes of bottles. They would remelt them, but that's a lot of energy loss, and it's a lot of waste to get back before they can get back to making good bottles. So we built an autonomous AI agent. So this is a type of industrial AI, and the type of industrial AI, as you mentioned, it's different than generative AI. The type of industrial AI that we talk about is generally divided into two broad categories. One is called autonomous AI. Autonomous AI is the most advanced AI that we build here, and it is able to make human-like decisions. So it's able to actually reason through. It's the only AI that's been proven to understand causal connection. It's able to understand that if I make a change now, it's going to have this impact in 3 minutes, 5 minutes, 20 minutes, whatever. So we were actually able to train that autonomous AI agent to be able to control that process as well as their expert operators.
Very cool.
So and part of that process is something called machine teaching. So that's where we actually sit down with their experts. So they had 2 experts in the world who are the best in the world at operating this process. We sat down with both of those guys, and we picked their brains. We said, train us like you would a new operator. And they taught us all the tips and tricks and everything we would need to know. And we built all of that into the autonomous AI. There's actually a mechanism to basically hand that over to the autonomous AI. And then we give it this simulation environment where it can play. And it learns how to not to do things and how to do things really, really well. By the time it's done, it trains for about a human day, but by the time it's done, it's like it's run that part of the process for 20 to 30 years. So it's like it's an expert in that part of the process. And in fact, when we debuted it, we had it running against the simulator in a conference room. We had those 2 experts with us, and we go at a very slow pace. So it can see right before it's going to make the move. It says, here's the next move I'm going to make. And it said, I'm going to make this move. And one of the experts 20-year guy, right? Knew everything there was to know about glass bottle making. He was like, that's not right. I don't know why it's going to do that. And we were like, let's just see what happens, right? Because humans have egos, right? And so we were like, but we were pretty confident that the agent was actually correct. This had been kind of a sticking point throughout the development of this one particular move that it wanted to make. And so we said, let's just see what happens. And so it makes the move. And wouldn't you know that within a couple minutes, we were back to making on-spec bottles. And he was shocked. He's like, that runs exactly counter to everything I thought I knew about this part, specific part of the process, and so, that's a big deal. Like, so now you've really outperformed that agent now has proven its ability to really outperform the experts, even at that point. So, and this is a decision support system. This is a system that is running today, and it sits on the plant, and it advises newer operators on here's the next best move that you can make. But there's still a human in the loop who's actually making that change. Okay, so they can choose not to take the recommendation. Okay, so there's an example of an autonomous AI one. That's process optimization. That's being able to make better product faster, better, cheaper. Okay, let me give you one more example then, because you asked about energy.
Yeah.
So I talked about there's two different categories of AI. I said we were talking about autonomous AI. The other type of AI is what's called traditional AI. Traditional AI is your analytical and ML models that have been around for a long time, right? These predate autonomous AI. They predate generative AI, certainly. They've been around for a long time, but still very capable models, right? So predictive quality and predictive set point and things like that. So we absolutely still do projects with that. But the autonomous AI, when we talk about getting to single and double-digit percentage returns, we typically have to go to autonomous AI because it's just more capable. It can handle more scenarios, more situations. So this energy one is also an autonomous AI project. So this was one for a life science manufacturer. And something you need to know about life science manufacturing, we talked about some plants, steel plants are still pretty dirty, and they're trying to change that image. But if you go in a life science plant, so this is a plant that is making the active pharmaceutical ingredient, the thing that does something in your drug, tablets. When you go in there, it is pristine. It is the cleanest. You can eat off any surface in this facility. It is the cleanest facility you've ever been in. And it has to be. And so part of that is that they have to control the environmental factors. So humidity, pressure, these are temperature. These are all important process parameters. So these aren't just about the comfort of the operators. These are actually important to making good product. And so it has to be controlled very tightly. But despite that, they put these very expensive environmental systems in, and then they're typically just set it and forget it. They set the parameters, and then they never touch them, right? And so this was a project where this life science customer wanted us to build an autonomous AI agent that could specifically make micro adjustments throughout the day. So we have these constraints. We have to maintain this pressure, this temperature, blah, 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 this humidity. But can we make micro adjustments throughout the day? There's no one whose full-time job is 24/7 to sit there and turn the knobs all day and make, Can we make micro adjustments throughout the day, taking into account things like outside temperature, energy demand, electricity costs? Can we make these adjustments, intelligent adjustments throughout the day, and try to squeeze out? And so that's what we did. And so by the end of this project, they ran it for a year, this autonomous AI agent, and it was an 8% reduction in energy utilization. And in some months, it went all the way up to 12%. But over the course of the whole year, it averaged out to about an 8% reduction, which was over $1 million annually.
Right.
And that was just one environmental system that was controlling. And now they're looking at expanding it out to the entire campus. So, again, like that's a big impact, being able to do that. And, one of the things that's funny about our industry is that even with controlling these environmental systems and stuff, people like round numbers. So if the environmental system is set to 69 or 70 or something like that, right? But what if it's 69.3? What if it's 70.1? What if, you know what I mean? The API doesn't care about round numbers. So those are where you can kind of, in the margin, you can start to get those increases and decreases. So those are the types of things that we're looking at when we're looking at those optimizations.
Super interesting. I have obviously a bunch of follow-up questions here. Maybe one of the first, I was Googling, I mean, you're probably aware of this. I'd forgotten about it. It was AlphaGo versus Lisadol. It,
Yes.
and I saw a documentary about this. I've also read a bunch. There was like, I think it was the second game, or maybe it was the third game, where AlphaGo created this new starting move that had never been
Yes.
thought of before. And Lisa
Yes.
Bowles is like this absolute genius Go player. And so, if I understood correctly in your process, like that kind of was starting to happen. Is
Correct.
that correct?
So
Yeah.
that, yes, and that's
Okay.
actually what we're building it on. So
Yeah.
when I say autonomous AI, that's more of kind of a marketing term, but the actual underlying algorithm is deep reinforcement learning, which came from
Gotcha.
DeepMind and AlphaGo. So I
Gotcha.
actually tell that story when I speak at trade shows on this. I actually talk about Lisa Doll
Right.
and AlphaGo beating Lisa Doll 4-1 in that initial match. And then I don't know if you know the whole story there after that. So after DeepMind built AlphaGo, then they built AlphaZero. Now
Yes.
that was built to play the game of chess, and it was unique in that it was not given any strategy. So it was just given the rules of chess and it was set to play against itself. There's about a dozen opening moves in the game of chess that humans have discovered over the centuries of us playing it. Independently, Alpha Zero discovered 10 of those 12 opening moves. And so it beat our best chess grandmasters, but then it went on to beat our best chess software, which in a lot of ways, and I've got a software background, so I'm sympathetic to it, but in a lot of ways, to me, that was more impressive because if you go back to the 90s with Deep Blue and IBM and beating Kasparov at chess, like that was a big deal in the 90s.
Right.
Now you can imagine in the decades since all of the heuristics and all of the algorithms and optimizations that have been built into our best chess software. And here comes AlphaZero with nothing more than the rules of chess and this deep reinforcement learning algorithm. And with the combination of those two things, it was actually able to beat our best chess software. So to me, that was pretty impressive. And then they went on, if you're a StarCraft player, they went on to build Alpha Star, which beat our best StarCraft grandmasters. And so deep reinforcement learning that has been around for well a decade now.
Yeah.
It was 2016, so it's been around for a decade. It's matured significantly. It's in production on plant floors, and so but it is still kind of treated kind of novel in our industry. So but that's something that to me has a much higher ceiling than the traditional AI. Traditional AI is great. We still do those predictive quality, predictive this, and computer vision is under that category. We still do all that cool stuff. But autonomous AI to me is the one that has the highest ceiling and can just because it can build long-term strategy and can act on it like a human can.
Hmm. So if I'm understanding the context that you gave at the beginning, which is labor shortage, currently, and it's only most likely going to increase over the next several years, we've got these phenomenal AI platforms or tools that are being adopted by these plant floors. I kind of see, however many years, 5, 10 years, many of these plants are going to be, whether they're not fully run by AI or at least heavily supported by these autonomous AI, industrial AI. How, like, do you have a fanciful number in your mind of like the total production capability increases, or is it going to be so efficient that it, while, as you said before, while the numbers are decreasing, we're just going to be able to keep pace with what happened like 5 years ago? How do you see things
Well,
turning out here?
so I've got some bad news on that front.
Okay.
So the manufacturing industry is very, very, very slow to adopt new
Right.
technology.
Right.
They are very risk averse, and for good reason. Like there's reasons why they still have equipment on the plant floor that's been there for 20, 30, sometimes 40, 50 years, and has not been upgraded. The reason why is because if they're not making product, they're not making money. And major, modernization efforts and trying to rip out this equipment and replace it is very, very expensive and it's very, very high risk. And so, unfortunately, it will probably take, I mean, I'm in it for the long haul. I've got a 15, 20-year horizon for when we see broad adoption of industrial AI in the manufacturing space. And I that's not me pulling a number out, out of thin air. When I started my career, there's this very specific kind of database in manufacturing. It's called a historian. But what it is it's a time series database. So I don't know if your listeners are familiar with time series databases, but they're just very efficient at storing timestamp value. That's all they do. Well, on the plant floor, that's everything. That's what we have pieces of equipment that at a given timestamp they can give you, here's the pressure, and the number of tags then that we record is in the tens of hundreds of thousands, right? So, but it's all timestamp value. So these are time series databases. They're called historians. And when I started my career, we were still very much educating our clients on why the value of a historian and storing this data in this time series format. So fast forward now 25 years, and it is only now that I would say we are at that point where historians are ubiquitous within our industry.
Okay, gotcha.
So I'm kind of mapping out this same arc here, and I'm saying I think it's going to be 15, 20 years before it's ubiquitous. The other factor that's at play here is that many of my clients don't want to turn over operation of the process to an AI for various risk and just, whatever. So I saw a study that was released in January of last year where they did a survey of manufacturing companies and asked them where are the number one places that you're looking or the value that you're trying to get out of AI on the plant floor. And the number one thing they said was decision support. So they still want humans in the loop. They just want AI to make those humans better, to make them smarter, and be able to optimize. And the other thing there is that, AI has this beautiful ability to then be retrained and redeployed. So now it can have extra capability and it can squeeze even more, production out of these processes. So we can continue to iterate on that, but still keep humans in the loop. So yeah, it's going to be, I think, a much longer timeline, and we may see some short-term pain because we can't deploy this AI fast enough. These projects take time. They're in a lot of ways, no one's ever tried to do this before, for this part of the process. So we're like explorers trying to figure this out. And there's not a lot of companies like us that can do this yet at scale. So it's going to take a while.
Right. Maybe one of the things that you said that would be interesting to go back to based on what you just said now. So with these two, 20, 30-year experts for the glass blowing and dialing, if manufacturing plants still want to have humans in the loop, is there maybe more acceptance of having like an AI, maybe not an agent, but some AI educational program that you can take the learnings from these experts who are now retiring, and then it's not necessarily a human, but it's maybe the best humans that have taught this AI that can now scale out to the new workforce across many different plants? Like, is that something that you or others are thinking about? If there's hesitancy to give actual decision making to AI programs?
Yeah. And it's happening right now, and it's happening in kind of two different ways. One is we talked about machine teaching. So that's a very operational focused mechanism for us to capture that process expertise, right? So we're sitting down with that expert and we're saying, teach us like you would a new operator. And they'll say things like, well, when the line's running hot, we do this. Well, what does hot mean, right? That's something, and then we'll ask them that, like, okay, what do you mean by hot? Well, it means that this is up and this thing and this is, blah, blah, blah. And so we can build an ML model that can detect that we're in that state, right?
Right.
With all the gray area we need. And then they'll say, when the line's running cool, then we tend to do this, right? What does that mean, right? And so we capture all of this, and by the time we're done, it looks like a workflow. And so that we then feed into the autonomous AI. And it's an iterative process. We'll come back and we'll say, hey, so we're doing really well in these cases, but in these cases, the AI is not doing well. It's underperforming even human operators. What's going on here? And then they'll go, oh, I forgot to tell you. when you're running that product, you have to make sure you turn this knob to, okay. All right. So then
Right.
we add that knowledge back into the workflow so, okay. So that's one area. And then the other area, and we haven't talked about it yet, but that's generative AI. So we are absolutely seeing that knowledge capture happening in the generative AI space.
Mhm.
And I am not opposed. I told you before we started recording, I've got strong opinions about generative AI on the plant floor. I'm not opposed to using generative AI to solve knowledge problems. That's what it was built to do.
Mhm.
And I think that in that case, it's a great idea. If you want to sit down, I've seen companies that are embarking on pilot programs where they're sitting down with those 20, 30-year experts before they retire, like a week before they
Mm.
retire, and they're literally having them talk to camera and explain everything that they can think of about every aspect. And they've got an interviewer who's literally guiding them and
Right.
trying to extract all that so they at least have it captured. And
Right.
they know
Right.
that they can feed that into generative AI and they can start to use that over the years. I'm not opposed to any of that, right? So generative AI is the right tool to solve knowledge problems, even in manufacturing. The thing I'm opposed to is that generative AI is not built to solve operational problems. And those are the types of problems that we see on the plant floor. Um, Not only is it not built, so it's the wrong tool to solve that problem, but it's worse than that because it's actually dangerous. So if you give the wrong information to the wrong person at the wrong time on the plant floor, worst case scenario is you could kill somebody, right? So
Yeah.
so this is still very much a high risk environment on the plant floor. There's a risk to life, limb, and property, and we have to be very careful about whatever technologies that we put down there. And one of the things that is disturbing to me is I'm seeing these AI vendors, many of them who came from the IT space, and who are coming down into the plant floor, and they're pushing their AI product onto the plant floor, their generative AI product onto the plant floor, and they're saying this is going to solve all your problems on the plant floor. Well, what do we know about generative AI? Some of the limitations. Obviously, the biggest one is hallucinations. So that's where, for your listeners who don't know, that's where the generative AI will literally make something up, just out of whole cloth, just make something up. On the plant floor, that is, I mean, again, that could have deadly consequences. That's a really bad situation. Some of this equipment, it's all dangerous. But some of these processes are dangerous just in and of themselves. I'm aware of a polymer customer where they had, this was in the 90s, but a polymer company where they had a runaway polymer reaction and it blew up the plant, and all that was left was a crater. The explosion could be heard 100 miles away. I mean, it's bad news. So,
Mhm.
you can have, chemical processes are really bad. I mean, there's a lot of really bad things that can
Yeah.
happen. So we don't want to mess around with generative AI in those types of situations and have the generative AI hallucinate something. And I've heard about RAG. I'm well aware of these efforts to ground generative AI in the truth. What I'm seeing is I'm seeing marginal improvements, but I use generative AI every day, and hallucinations are still very much a daily occurrence with
Mhm.
with
Mhm.
generative AI. So yes, all the RAG in the world and all these efforts to ground it, even in spite of that. So that's one problem. But the second big problem, and the other limitation that a lot of people aren't aware of with generative AI, is it does not have the ability to reason. So Apple proved that with two landmark studies, that generative AI, LLMs in particular, are not actually able to reason. All of the reasoning that we ascribe to them is just us projecting, like we would project onto anything, like humans love to do when we anthropomorphize things. We're projecting intelligence onto something that really hasn't earned that. And so it's not actually able to reason. And so again, on the plant floor, the operational types of problems that we face, we have to, whatever AI, whatever is down there has to understand cause and effect. It has to
Mhm.
understand
Mhm.
causal relationships between different things. And so if I take this action, what's the possible outcome of that? And generative AI does not understand that. And so those two limitations in particular are pretty nasty. And so those are ones that those are the primary reasons why I'm saying use generative AI to solve knowledge problems, but for operational types of problems, we already have a tool to solve that, and that's autonomous AI. That's deep reinforcement learning, and it is able to reason through those things, and it is able to give you deterministic repeatable results, right? Because that's the other thing with generative AI, is that that's the third limitation, is that it can't give you deterministic results. With deep reinforcement learning, AI, autonomous AI, we're actually able to get repeatable deterministic results. And that's a really important thing on the plant floor.
Super interesting. I see the time's winding down here a little bit, Brian. We've touched a little bit on the future of manufacturing. One question that I think I want to ask you, I think it kind of falls into this hype cycle of whether it's AI or automation in general, is these dark factories and the factories of the future, which are fully autonomous, right? I I don't, and I haven't looked for a while, but I don't know if there are any fully automated dark factories on the planet. Not just talking about the West, but maybe in China or other places. Is that with these new kind of industrial AI technologies that are being built out, is that something that is feasible, is possible in the future? Is it going to be the thing that helps with labor shortages across the world if it's ever able to be built? What are your thoughts on that?
Yeah. Okay. So there's a lot there to unpack. So yeah, these lights out factories has been talked about now for most of my career.
Right.
And I would agree. I mean, I've had clients who claim they have, our site and wherever is lights out. Okay. I don't know that I truly believe that those types of places exist. I think that there can be parts of the plant that can be lights out. So our most advanced factories, things like the Tesla Gigafactory, things like the Amazon fulfillment center. So I've been, if you ever get a chance to go in an Amazon fulfillment center, and I don't work for them, I'm not a shill for them, but just to give you an idea, or even look online, they got videos of these things. This is the most advanced factories that I've ever seen. And this is my job, right? So this is, and I was in an Amazon fulfillment center, and I'm looking around like it's my first day in a factory. Like it was stuff I'd never seen before. And they were like, this is a Gen 9 factory and we're up to Gen 12 or something like that. So this isn't even our most advanced factory. And so, okay, so let's talk about lights out. There is a portion of the Amazon fulfillment center that is lights out. There's no lights over there. And it's working, like it does its thing. So are we going to get there? Yes, but that is the most advanced factory I've ever been in. To get to there, like back to what I was saying, that's 20, 30 years down the road to get the average factory to there. And I will say, no disrespect to Amazon, because they're amazing what they do, but it's a little bit simpler than what some of these processes, right? So making product in a lot of ways is a little bit more complicated than just sorting. And now they'll tell me that I'm wrong, but okay. Okay. So how do we get there? I think it's more important rather than saying I want a lights out factory tomorrow, which is not going to happen. I think it's more important to say 20 years from now, we want to have major portions of our factories to be lights out. How can we get to where 3/4 of my factory is more or less automated? Well, to get there, we got to plan out a trajectory. And right now, especially for US manufacturing, and this plays into this whole onshoring thing that we're trying to do, right? We're trying to reshore US manufacturing. Here's the problem, is that just like I described in that glass bottom example, too much of US manufacturing, the process is an art, not a science. It's just like guess and check. And the final quality is dependent on the skill of the operator. So we have to solve that first, right? And so here's the example that I typically use, and we can wrap on this. But if you look at a McDonald's, when McDonald's goes out into the market, they don't go out and look for cooks like a diner would look for a cook, right? They look for a person. And then we've all seen, behind the scenes of how, videos of how McDonald's works. So a person loads all the frozen pucks into a machine and they hit a button and the machine does all the work, right? And then the human does effectively everything that they would have a hard time building a robot to do, right? All the things, the dexterity things, and it's not even really decision making, but those types of things are the things that, that they've offloaded to the human. We don't even have that level of automation in our plants today.
Gotcha.
We have to get to that level of automation where I can hire someone, because that's the kind of workforce that we're seeing.
Right,
Stick it
right.
for a couple weeks. And right now, I got clients that are telling me it takes 2 to 3 weeks to train a new person, and they might be gone in a month. Like, that's not sustainable. Right? So you have to get to that McDonald's level of automation, and that will take years. That will take probably decades for us to be able to get to there. Once we get there, now we can start to look at higher levels of automation and AI to be able to get to this lights out that everyone wants to eventually get to. So.
Super clear. Well, I think that's a perfect picture and clearly understood. As somebody who worked at McDonald's way back in the day as one of his first jobs, it's I understand the need for just slotting people into low decision making, work like that. It's very, very interesting. Bryan, thank you so much for coming on the podcast. It was an absolute pleasure. Very robust answers, and I think you've painted a real clear picture of what's happening now and likely what might happen in the next 10, 15, 20 years. So really great to have you on the podcast. Where would you like people to check out the work? I'm assuming LinkedIn and website we can have up on the show notes. Anything else?
Yeah, Robasys website, and yeah, look me up on LinkedIn and feel free to connect with me there. And I'm always happy to talk to anyone about any of this stuff. But thanks, Mark. I appreciate it.
Perfect. Well, thank you so much. Well, thanks for listening to this week's Future Tech and Foresight podcast. If you like what you've heard here, there are, of course, a number of ways that you can support the podcast. The best way would be to leave a review on Apple Podcasts or give a rating on Spotify, which you can find a step-by-step explanation for on the futuretechandforesight.com website. Alternatively, feel free to leave a comment either on the episode show notes or the YouTube channel where you can see video recordings of the interviews. And finally, if you are part of an organization that is aware of the disruptive and transformational impact that emerging and future technologies will bring and want to know more, please get in touch to hear about the strategic foresight services that we offer and how we can help future-proof your organization and take advantage of the phenomenal opportunities available to survive and thrive in the future.
A lot of future-shocked people and future-shocked institutions in our society are simply overwhelmed.
Once there is superintelligence, the fate of humanity may depend on what the superintelligence does.
Science fact is catching up to science fiction.
The first truly intelligent machine will be the last invention that humanity needs to make.
The only scarcity that will exist in the future is that which we decide to create ourselves as humans.
Within a 10-year design revolution, we can have all humanity living the highest standard of living anybody's ever known.
Progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity.
We are probably one of the last generations of Homo sapiens.
Every single headline points to the birth pangs of a Type 1 civilization.